This next video is talking about empirical versus molecular. These are two different types of formulas, and you just have to know the difference between them. It's fairly simple. So let's get started. So the first slide is just telling you the definitions. Empirical formula is the simplest whole number ratio, meaning it can't be reduced. Okay, it's the lowest possible it can go. Nothing can go into it anymore. The molecular formula is the actual number of atoms of each element in a compound. So it is possible to reduce. So an example here, glucose. When you mention glucose, the actual molecular formula of it is C6H12O6. This means that there are 6 carbons, 12 hydrogens, and 6 oxygens. Anytime you look at a molecule of glucose, those are the exact number of atoms in that molecule. But if you were to reduce it, meaning 6 goes into 6 one time, 6 goes into 12 two times, 6 goes into 6 one time. This is your empirical because it is reduced to the lowest possible. Okay, so this is the ratio here between the carbon, hydrogen, and oxygens. So just to run through some examples here, dinitrogen tetraoxide, if you write that out, is N2O4, which would be its molecular formula, meaning you have 2 nitrogens for every 4 oxygens. That's the exact number. If you reduce that, you get NO2, which this means this is your empirical formula. Okay, boron trihydride, if you write that out, you get BH3. Now that's the actual number of atoms in the compound, so BH3 is actually both the molecular and the empirical. Okay, then tetraphosphorus decoxide means P4O10, so it can be reduced, so this is the molecular, and the empirical would then be P2O5. So again, it all comes back to these two definitions. In the next couple videos, you're going to actually have to calculate and find those formulas when you're given numbers.